All right. What we're going to do here is that we're going to go through how to curve sketch and how to find the derivatives of different graphs and functions. So first off, we have an easy one. What we want to do here is we want to find the derivative of sketched derivative of this function f. Now to figure out the derivative of this function, you have to remember one key thing. Derivatives, all right, are slopes of curves. So f prime is a slope of the curve. When we do this, we're going to be looking here and we're trying to figure out, okay, we notice that we have a line. Well, lines have a constant slope. So essentially, we just need to figure out the slope of this line, and therefore f prime is going to be a constant. Okay, so figure out 2 points. Well, I'm going to look right here. It looks like we got a slope here. This slope is 1 running, appears to be like 1/2. So we'll have rise 1 running of 1/2. So our slope, or f prime, should equal 2. So f prime right here, when we graph this, is going to be 2. And that is going to be our derivative equation. And that's our graph. Pretty easy, right? Let's try another one. This is a little bit more difficult. What we have here is a graph that's shown. It looks like a quartic function. We want to find the derivative of this. Once again, f prime, when we're going to graph, are the slopes of f. It's imperative that you understand what you're given and what you're trying to find. Okay, so right here, if we got here, we notice that f is decreasing. Well, going through, we understand that right here, f prime, then if f is decreasing, we know then that, all right, therefore, f prime is going to be negative. So all these values, all right, up to this point, and actually this is where we're going to have a tangent line. All right, so where we have this change is our critical point, and that's going to be a 0. And all these values are going to be negative from the critical point, all right, up to where f is decreasing. So that's where f prime is negative. We then realize right here that this is going back up. When f is increasing, we know therefore that f prime is going to be greater than 0. It's going to be positive. So on this interval, all right, from here, and then once again we have another critical point. Okay, another critical point right there. All right, so what's going to happen is it's going to go up. And then we know that it's going to go back down right here at 0. Right there. Okay? Because once again we have a change. All right? From here then, we realize that it's decreasing. And we know that when f decreases, f prime is negative. So that means it's going to go negative. Come to this point, once again, we have another critical point. Put it right there. It's going to be negative. And then we realize that this function is increasing. Therefore, whenever f prime is increasing, so whenever f is increasing, f prime is going to be positive, and it's going to go up like so. That would be a sketch of this graph. Probably you could do a little bit better symmetry, but that is what we have. All right, so we create a quartic and create a cubic function. Notice how at each one of these maximins where we have horizontal tangents, where there's a change, all right, these critical points, we have zeros. Okay, and then we have positive and negative values at the increasing and decreasing intervals of f. Well, I hope that helps you out on how to sketch the graphs of the derivatives of f. Key thing is identify the slopes. Whenever f is decreasing, f prime is positive. Negative. Whenever f is increasing, f prime is negative. And where do you have maximins that change? That's where you have critical points, and that's where f prime is 0. All right. Well, good luck. God bless with the rest of them, and have a lot of fun.